AFGCU college students, this is Lucas Wilkerson, the math coach here at FGCU, and I'm going to be going over the review sheets from section 1.5, 1.6, and 1.7. Just a reminder, check the emails with all the information that shows when I'm meeting with supplemental teaching sessions, and also when I'm holding office hours in SOBI. All right, so we're going to start with question number 2, actually. And if you want to see all these questions worked out, come Tuesday nights to the supplemental teaching session. So we're trying to solve the equation by factoring. And when we look at this question number 2, there's no simple and straightforward way of factoring because our x squared is being multiplied by 15. So the simplest method when you encounter this is what we call AC grouping method. We label these constants as A, B, and C. The AC grouping method takes A times C, which in this case would be 15 times 8, and we see that they multiply out to 120. The next trick is to find when they're divisible and they add up to 26 over here, when they add up to the B term. So if you punch through your calculator and go through all of them, you're going to find 6 and 20. 6 and 20 obviously add up to 26, and they also multiply to 120. So then the next step that we do is we come over here and we split them. So we'll have this plus 6x, and then we'll also have this plus 20x. So you see we get that from this AC grouping method right here. Next, we're going to kind of treat them as two separate pieces just to make it easier for us to work with and simpler to understand. So this 15x squared plus 6x, I want to look for something to take out, and I can take out the 3x. Turns it into this. Now for our second piece, I see we can take out a 4, and that gives us 5x plus 2. Of course, all this is just still equal to 0. We're not really doing anything with the right-hand side. And what I notice is that both of these are equal, and they're just being multiplied by something, by a 3x or a 4. So what I'm going to do is I'm just going to rearrange this so it's even simpler. I'm going to take our 3x and our 4, just move them over to here, and just multiply them by 5x plus 2. Now it's simple enough that we can just set each piece equal to 0 and solve. So we'll have 3x plus 4 equals 0. Subtract 4, move it to the right hand side, divide by 3. We have negative 4 over 3 is one of the answers. Do the same thing. And these would be our two answers for question number 2. We're also going to do question number 3 right here. It says solve the equation by the square root property. So in this case, we can just simply take the square root. We don't really need to move anything around. We have the squared part right here, so let's just keep it nice and simple. And we'll take the square root, both sides. The left-hand side is pretty simple. I mean, it's just going to turn to x minus 3. But the right-hand side is going to be a little more complicated. Since we have a negative under the radical, we want to remember that the imaginary number I is equal to the square root of 1. So we're going to want to take an I out of here and leave us with just a positive 121. And then if we use our calculators, we're going to see that we get an 11. But it's also important, since we took the square root, we need to have that plus or minus sign. So we're going to get x minus 3 equals plus or minus 11i. Now we'll just solve for x. We'll add 3 to both sides. Now we get 3 plus or minus 11i. And that'll be our final answer. The trick with this is just remembering what I is, so we can deal with the -1, and then remembering this plus or minus sign we need when we take the square root. Now looking at number 4, it says solve the equation by completing the square. So to do that, we're going to move the 26 to the other side because there's no good way to factor with this 26 here. So that's just subtracting the 26 to both sides. Next, we're going to want to look for a new term to put next to 14x, one that'll simplify easy, one that'll just be completing the square. So when I say completing the square, we mean like if we get x plus 3 times x plus 3, that's just x plus 3 squared. That's easy to work with. But in our problem, we're going to need a different constant to make that happen. So the easiest way when a question asks you to complete the square is to use this little formula, which is b over 2 squared. Remember the constants go a, b, c. So in this case, we're going to have 14 over 2 squared, which is just 7 squared, which is 49. So it means we're going to add 49 to both sides, and you'll see why this is helpful in a second. We add 49 here, add positive 49 and negative 26, we'll just get positive 23. And now what we can do is you can notice just by doing basic factoring, we get x plus 7 times x plus 7, which is equal to 23 over here. We can simplify that just to x plus 7 squared equals 23. It's sort of like the previous problem. We're just going to take the square root of both sides, make it nice and easy. And doing that, we get this. Simplifying again. Actually, no, not simplifying. We're just going to move the 7 to the other side because we can't take the square root of 23 and we can't really simplify it. We get -7 plus or minus the square root of 23. And though this answer is messy, it logically makes sense, and it's our final answer. Next, we gotta solve the equation using the quadratic formula. This is probably the easiest way to go about factoring or not factoring, solving for x, and it works for any quadratic equation that looks like this, with the x squared as a leading coefficient. So to do that, we just take a, b, and c, and then you're going to want to have the quadratic formula memorized. That's the harder part. It's going to be x equals this big fraction. It's going to be negative b plus or minus the square root of b squared minus 4ac over 2a. The good part is once you remember that, it just pretty much comes down to plugging in the pieces. So for instance, a here is 6, b is 12, and c is 5. It's also important to remember if like the equation was like this, say where there's a -5 here, then our c would be -5. So just make sure when you're determining what a, b, and c are, you carry the sign with it. Otherwise your answer will be wrong. So using this formula, I'm just simply plugging in the information we're given, not even really even doing like math, just plugging in the information we're given. And now you just begin to punch this in on your calculator. You would see 12 squared is just 144. All this right here is 120. Perfect. And then 24s can be simplified just using this tree method right here. It can be divided to 2 and 12, and then 12 can be divided to 2 and 6, and then 6 to 2 and 3. And we see we have a pair right here, the two 2's. So we can change this to 2 outside the radical, and then we take this 2 and multiply it by the 3, and we have 6 in the radical. So that simplifies this negative 12 plus or minus 2 square root of 6 divided by 12. We can simplify it one more time. Negative 6 over 6 plus or minus the square root of 6. And that would be our final answer. It's just plugging it in and doing some factoring. Now for the last question on 1.5, compute the discriminant, then determine the number and type of solutions for the given equation. So the discriminant is like one piece of the quadratic formula. The discriminant is b squared minus 4ac. We're just going to take a, b, and c. I'll write what they are on the side. A is 1, because there's nothing being multiplied by the x squared. B is negative 12. We've got to make sure to carry that negative sign. And then C is 36. Now we just plug in for the discriminant. Use our calculators. We'd get this. And then that's 0. The next part with using the discriminant to determine the type of solution is basically just going to be memorizing what your notes have given you. If you have a 0, if you have a negative, and you have a positive solution, they all indicate different things. I encourage you to go back in your notes and look at how your teachers, your professors prefer you to do that. In this case, we have a 0, and that is one real, rational solution. All right, here we're just going to solve number 2. It says solve the radical equation and check all the proposed solutions. So when we need to solve a radical equation and check all proposed solutions, the easiest thing is going to be to isolate the radical, especially since we have an x in it. So we'll just subtract 6 from both sides. Which simplifies to this. Next, we'll just square both sides. Which gives us 2x. Then if we expand this, just x minus 4, x minus 4. And then since we have a 2x on the left side, we're going to expand the right side because it'll help us shuffle things around. So if you FOIL this out, you'll get x squared minus 4x minus 4x plus 16. Then we'll just subtract 2x and put it on the other side. And then when we simplify, we'll get x squared minus 10x, just adding all the minus 4x, and minus 2x. And we'll get plus 16. So next we'll just kind of want to refactor this again. So when the x squared is just being multiplied by 1, the easiest way to think about this is we need two numbers that add to negative 10, but they multiply to positive 16. So if you mess around your calculator for a bit, you're going to find you can get x minus 8 and x minus 2. If we set these equal to 0 and solve, we'll get x equal to 8, x equal to 2. And the important thing in this equation, in this problem, is when we solve the radical, we need to check the proposed solutions to make sure they're correct. And so we'll just start back up here. We're going to check, let's do x equals 8. And all I do is I take what I solve for x, and I plug it back in our original equation. So it looks something like this. And you can just, there's no factoring or anything. I mean, you can just use your calculator, work through this. And then you see we get 10 equals 10, which is true. So yeah, this solution makes sense. So x equals 8 is a solution. Next, we'll check x equals to 2. Again, you can just use your calculator and work through this. But what you'll get this time is you'll actually get 8 equals 4. And we know that's not true at all. 8 is not the same as 4. So x equals 2 is actually not one of our solutions. The only solution we have is this x equals 8. Next we'll do problem number 4. It says solve the equation by making the appropriate substitution. Or wait a second. Is this the correct problem? Oh yeah, it is. Sorry, I'm looking at the wrong thing on my paper. Here we go. So yeah, this is going to be u substitution. You see that this equation looks a lot different than our other ones. Like the one we just solved earlier, we have a bunch of x squares. Here we have x being raised to the fourth, and that is just going to be way too complicated to factor. So what we're going to do is we're going to change it just for a little bit. We're going to let u equal x squared, because that's this middle term right here. And that means that u squared equals x to the fourth, which is our leading term right there. And what that'll allow us to do is make this problem look like something we usually work with. So x to the fourth becomes u squared. Negative 20x squared becomes negative 20u. And then the minus 125 stays the same. We'll just factor. And this is just the same as what I was doing earlier with the multiply and add. You can get u minus 25, u plus 5. Solve for u. Move the 25 to the other side. And we gotta make sure when we solve it like this for u, we need to change u back to the x squared. So x squared equals 25. Take the square root of both sides. And x is equal to plus or minus 5. Do the other one. U is equal to 5. Actually, negative 5, my bad. Change that to x squared. Take the square root of both sides. And we're going to get x is equal to plus or minus. We need to get rid of the negatives, so we'll take an I out. I square root of 5. And that's how you would solve this one with u substitution. Alright, now we're going to do number 5. Solve the absolute value inequality. Use interval notation to express the solution set and graph the solution set on the number line. So looking at number 5 right here, we have the absolute value of x minus 9 plus 5 is less than or equal to 13. Let's start by just moving the 5 to the other side. So we'll subtract both sides by 5. It gives us 8 over here. That important rule to remember is when it's less than or equal to, or just less than, we rewrite as a compound inequality. And hopefully my handwriting is okay enough. And the compound inequality would look sort of like this, the way to express it. It's just going to be taking what's on the right side, have a negative on the left, positive on the right, and the equation in the middle. So what that looks like for our problem, probably an easier way to visualize it, just negative 8. So we took the positive 8, made it negative, less than or equal to x minus 9, which was in the absolute value, is less than or equal to positive 8. Then we're going to add plus 9 to all sides. So the left side, the middle side, and the right side, which gives us 1. Just leaves us with x here. Gives us 17 over here. And this would be our answer. It's really not hard to solve. It's just going to be hard to remember the rules that I'm going over with it. And then to graph it, we're going to want to use the brackets because that means it also includes that it's equal. If you did the parentheses, that would be like not equal. Brackets mean it's equal. Then this is going to be 1. And this is going to be 17. You can just label them how you want. And then they have everything on this inside. And that's just from observing the answer we got. The answers have to be greater than 1, less than 17, so it look like something like that on the graph. Moving on to number 6. We're just going to start by subtracting 2. And then we need to notice the sign this time is greater than or equal to, so the rule is a little bit different. So when it's greater than or equal to, or just regular greater than, write as 2 separate inequalities. Sorry, my handwriting is not the best. So just one like this, and one like this. So for our problem, it means we're going to have 1 minus x over 2 is greater than 3. And we're going to have 1 minus x squared. And we flip the sign, is less than or equal to negative 3. We'll just solve both of them. So we'll start with the left one over here first. Start by subtracting 1 to both sides. Then we'll multiply by negative 2. And when you multiply or divide, you're going to want to make sure you flip the sign over to the other side. So it ends up like this. Now looking at the equation on the right side, I'm going to subtract 1 from both sides. Then we're going to multiply by negative 2. I have to flip the sign since we're multiplying. It gives us positive 8. Those will be our two answers. X needs to be less than or equal to negative 4, but x also needs to be greater than or equal to 8. Draw that. This would be our negative 4. We need all the answers that are equal or less than. The next is also going to be positive 8, which I'll draw right here, and all the answers will be greater than or equal to. So it looks like that.